Here we are in section 4-3, exercises 16 through 18, where we're going to graph the solution to the systems of inequalities. So here we have an inequality, and this will shade half on one side of a line. That will shade half of the plane on one side of a line. So we'll have where those two intersect. And then we have to label the vertices. So where the two lines, where it's equal to, cross. All right, so we'll do these with colors. Okay, so this one, 4x plus 7y is less than 2. Let's get y by itself. Subtract 4x from both sides, and we have 7y less than negative 4x plus 2. Divide by 7 everywhere. Divide by 7, and we get y less than negative 4/7 x plus 2/7. So that's positive 2/7 is about right there, and then down 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, somewhere about in there. And notice this is a dashed line, so this will go down something like that. Then on the other one, we'll do that in a different color here. 3x minus y is less than or equal to 14. So subtract 3x and we get negative y less than or equal to negative 3x plus 14. Divide by a negative 1 and we get y. We're dividing by a negative 1, so this guy switches direction. So it goes that way, greater than or equal to positive 3x minus 14. That's dividing everything by a negative 1, and so we're down at negative 14 down here and up 3 over 1, something like that. And this is a solid line. Oh shoot, I always forget this. Y is less than on the blue one, so we are down from that line. And then on this one, this is a solid line going up like that. Good. And it says y is greater than, so we are above the line. So we're that side of it. So we must be out here somewhere. So let's pick a color and represent where those two cross is out here in this area. So we just need to find this vertex right there. So if we do that, we're seeing where the blue line and the green line intersect, and that is, if we write it out here, we have 4x plus 7y equals to 2. That's where the blue line is solid, so that's what we're going to use here, and 3x minus y equals 14. All right, so how do we solve this system of equations? Well, it looks like it's prime set up for elimination. So if we times this guy by 7, we now have 21x minus 7y equals 98. So if we add the top and the bottom, we get 25x. The y's now go away, poof, gone, and 2 plus 98 is 100. So we get x equals 4. Now once we have the x coordinate, okay, so we got 4 something, stick 4 back up in for x, and we'll stick it right here. So we get 3 times 4 is 12 minus y equals 14. Subtract 12 from both sides, we get minus y equals 2. Y equals a negative 2. So the y coordinate is a negative 2. That's 4, negative 2 is the vertex here. All right, number 17. Let's take this top guy and make it orange. Solve for y, and we get y is greater than or equal to negative 3x minus 2. So we're down here 0, negative 2, and a slope of negative 3, which is down 3 over 1, and it is a solid line. There we go. That looks all right. And it says y is greater than, so we are shading up this way. All right, now let's pick another color for this second one. 3x minus y is less than or equal to negative 16. Subtract 3x from both sides, and we get y is less than or equal to negative 3x minus 16. And divide by a negative 1. And, oh, that's a minus y. Now divide by a negative 1, and we get y is greater than or equal to. Notice we switched the direction of the inequality because we divided by a negative 1. 3x plus 16. So maybe I should note that negative 1 divided by negative 1 divided by negative 1. Okay, so here we're at positive 16, like up there somewhere, and up 3 over 1. Solid line, like that. And so we're coming down like this guy somehow. All right, and it says y is greater than, so we're on that side of the line. So far we're up in this area right here. Good. And the last says, let's pick another color. Y is less than or equal to 10. So 10 is somewhere up here. And we graph y equal to 10. And of course, less than would be down. All right, so that means that put all those together, and it looks like we are right here in this little section where all three of those areas cross. We're below the green, to the left or up of the blue line, and up of the orange line is right in there. All right, so it looks like we actually have three vertices we have to find. So that's good to know. So if we're going to find this bottom one, this is where the orange and the blue cross. So the orange line would be a 3x plus y equals 2. And again, we're wanting to find exactly where they cross. So we've got to use the equals sign to get right on that line. And the blue is 3x minus y equals negative 16. Okay, so let's go ahead and solve these. And what do we get here? Oh, it's elimination. We can do this. Add those and we get 6x equals negative. Oh, that was a negative 2. Sorry about that. Negative 2 right there. Almost messed that guy up. So that's a negative 18, if I'm not mistaken there. Good. So x equals a negative 3. And then if we stick this in right here, we have 3 times negative 3 is negative 9, plus 2 is negative, plus y is a negative 2. Add 9 over and we get y equals 7. So this point right here is negative 3, 7. All right, let's solve these other guys here. So if we take the orange one, which is 3x plus y equals a negative 2. And we take the green one, y equals 10. We'll get that point right up there at the top. Let's see if we can get a different color out there and mark him. So this guy right here, this brown one. So if we do that, oh look, we've got y is already 10. We know that y is 10. So let's stick that in here and we get 3x plus 10 equals negative 2. Subtract 10 and we get 3x equals a negative 12. That means x equals a negative 4. All right, so that guy right there gives us negative 4, 10 as that option. Okay, and the last one. Let's see, we've got the blue line and the green line crossing. To create that guy right there, we'll make him bright pink so we can tell what we're doing here. This is the blue line crossing, which is 3x minus y equals negative 16 right there. That's the blue one. Crossing the green is y equals 10. So bright pink, so we know it's something 10. And so let's stick it in and we get 3x minus 10 equals negative 16. Add 10 over, we get 3x equals negative 6. X equals a negative 2. So that's a negative 2, 10. So we see we have 3 corners on this particular one, and we had to cross the lines 2 at a time to get these 3 corners. Excellent. All right, number 18. Let's do this again. 18. So we've got, do this blue one, x minus y less than 2. Let's get y by itself, and we have negative y less than negative x plus 2. Divide by a negative 1, and that's y greater than x minus 2, like that. So we're at negative 2, and we're up 1 over 1. And so this dashed line coming right through here. There we go. And y is on the bigger side of the line, the tall upper side. Y is greater than. So we're right in here. All right, now let's do the next one. Let's do a bright red on this guy. 3x minus plus y is less than 10. Solve for y. Subtract 3x from both sides, and we get y is less than negative 3x plus 10. So we're up here at positive 10, somewhere like that. And we're going to go down 3 over 1. And this is a dashed line as well. There we go, like that. And that is y is less than. So we're going to go down like this. So right now we're in here. And then we have the final one. Let's go ahead and use purple. X is greater than 2. So, oh, well, that one's nice. 2 is right about in here. And so we go where X is 2. And then, ooh, or somewhere right in here. And graph that line, dashed again, and greater than. So our final one, let's go ahead and mark it with a dark gray or something, is right in this little area here. Alrighty, so with that, we've got 3 corners again. Let's do this green one right here. That green dot right there is where the purple line and the red line intersect. So let's take the red line, which is 3x plus y equals 10, and the purple line, which is x equals 2. Notice we're right on lines. Even though these are not technically part of the answer in here, that is the corner of the answer. So let's go ahead and substitute this in. So 2 goes in for x, and we get 6 plus y equals 10, y equals 4. So the green one is 2, 4. 2 comma 4. All right, let's try this light blue color right over here where these two meet. This is where the blue and the red cross. So let's get the blue line, x minus y equals 2, and the red line is this one, 3x plus y equals 10. And notice it is set up perfectly for elimination. So if we eliminate those, this blue point will come out when we add these two together, and we get 4x equals 12, x equals 3, so that's half of it, 3 what? And stick that guy right up, say there. We get 3 minus y equals 2. Subtract 3, we get minus y equals a negative 1, and divide by a negative 1, y equals 1. So this is the point 3, 1. And then the final one. Let's do an orange dot right down there on the middle of that. Good. And we get, this is where the purple line and the blue line intersect. So blue line, x minus y equals 2. And the purple line, x equals 2. Again, this is prime for substitution. We can stick that right up in there. And we end up with 2 minus y equals 2. Subtract 2, we get minus y equals 0. Divide by negative 1, y equals 0. So this guy right here, let's draw it out here, is 2 over 0. Ooh, we were a little bit off on our graph there, but 2, 0. So the answer is that little shaded gray region in there, and the corners of the region are 2, 4, where the purple and the red cross, 3, 1, where the red and the blue cross, and then that guy right there where the blue and the purple cross. And those are the vertices of the solution.